For example, now we have a beam, and in this beam there is a load P1, and this beam P1, due to this P1 there is deflection, and that deflection, for example, due to this load, this deflection is like 10 mm, and due to this load P2, the deflection is more, like 20 mm. So if we want to see the combined effect of these two loads, for example, this load is 10 kilonewton and this load is like 20 kilonewton. So if you want to see the combined effect, like what will be the deflection at 30 when P is equal to 30? So according to the principle of superposition, you can add 10 plus 20, 30 millimeter. The same condition, everything is same. The beam length, span, all other parameters are constant. But for that, there are certain conditions that need to be satisfied. For example, this material is an ideal material, like a rubber, like a spring. But in real life, we don't have ideal materials like concrete. Do you understand? You know that the concrete is a non-homogeneous or heterogeneous material. So concrete do not obey any Hooke's law. But steel, what about steel? Steel obeys Hooke's law?
Yes.
How many of you say yes?
Yes and no. In the elastic region, it does.
Yeah.
Beyond that, it doesn't.
Yes, he's right. You know that this curve is a stress strain curve for a steel rebar. Up to this point, if you apply any force or any stress up to this point, and then you remove, it will go back. It is elastic. So it means that till this point you can use the principle of superposition for steel. Okay? But what about this point? If you apply some force and steel has, the stress has gone to this point, then its behavior is not elastic. It will not go back to the original shape. It will be deformed. There will be some permanent or plastic deformations stored in the material. Do you understand?
Yes.
Okay, so for this, the material should obey Hooke's law. Luckily or unluckily, in your book, there is no problem which discuss the non-homogeneous or heterogeneous material. So you are very lucky or unlucky? Maybe both. Okay. So that's why it is written in bold and in red that the material obeys Hooke's law and the deformation is small. Okay. Do you have any question from this? If you want to see the combined effect of a load under same conditions, you can add these two loads to get the total deformations, provided that the material obeys Hooke's law and the deformation is small. The same thing, this is the same thing, but it is in terms of support. For example, if you have two beams, like beam on the left and beam on the right, and the reaction on the left side is BA dash, HA dash, and the reaction on the right side BA double dash and HA double dash. If material obeys Hooke's law, material is homogeneous, so the combined reaction under P1 and P2 will be the sum of these two. It's very simple. Do you understand? You can do that. internal loadings. Let me confuse you. Am I allowed? Stress is due to strain or strain is due to stress?
Strain is due to stress.
Strain is due to stress. Okay, it means that you apply some force and then there is strain. Are you sure?
Well, if we look at the graph,
Okay. For example, there is a rebar. There's a rebar. You don't apply force. You try to move this rebar 10 mm upward on both sides. So what will happen?
it will
Extend.
elongate and its diameter will shorten.
But what is happening? I mean, do you need some force?
Yes.
Yes.
So it means if you apply some force, then there will be some deformation.
Yes.
So which comes first?
Both.
You know, the stress strain curve you have plotted maybe in strength of material or like in mechanics of solid one, you apply deformation. And to give, for example, to give this deformation, you need some force. Do you understand? And from where that force is coming and how much is that force?
From the stress multiplied with the area.
When you pull any material, so what is happening? You are giving deformation, you are not applying force. So the material itself tries to resist. That resistance is known as what? What is stress? What is the difference between stress and pressure?
Area.
What is stress? Definition of stress.
Force over area.
And what is the definition of pressure?
Same.
Then what is the difference?
The pressure depends on the air.
Sorry?
The pressure depends on the air and the stress.
The pressure depends upon area and stress depends upon
No,
Pressure.
Air.
Pressure is a type of stress. Stress can be like,
anything.
yeah,
No.
Stress material over material, but the pressure is about
Let
the
me tell you.
area.
The pressure is applied force and stress is the internal resistance of material per unit area. If you understand, it's a very, very delicate point. There's a rebar, you try to move that rebar by 10 mm. And what rebar is doing, rebar is trying to resist your force. But you have to move it. So once you move, there will be resistance. So that resistance divided by area is known as stress. For example, someone of you is standing here. I put a load on his head like 10 kg. So the 10 kg is applied force. And you are also trying to resist that force upward. That is your resistance. And that is how much?
10 kg upwards.
10 kg upward. Okay? And then I put 20 kg.
You will do more, 20 kg.
Then your resistance will be?
30.
And if I put 100 kg,
You're crushed.
you will?
I put that.
Depends on you. Depends on you.
You will fell down.
Yes.
I think it's very hard for an average people like me to lift like 100 kg. It's very hard, of course. So it means your resistance has
Like,
gone.
yeah.
So that is the point when stress becomes zero. But external force is there. The same thing is happening in the structure. When the structure becomes crack or break, you apply some force and beam breaks down. It means that the internal resistance has gone. Internal stress has gone. Okay? And that, for example, like this, if you see this slide, if you apply any force, if you apply a moment, there is a beam, you apply a moment, force, and due to this force there will be a bending moment here. You know that there will be bending here?
Yes.
So you have two forces. One is the bending here, like how much will be that? If the L is the length of the beam, then how much will be the moment? PL over 4. If L is the total length and the load is in the mid, then this moment is PL over 4. Okay? That is what? That is the applied moment. And how much is the resistance? Equal, but in opposite direction. The beam is trying to resist. Okay? But you increase load more, the resistance becomes more. But if you increase load greater than the resistance, then it will fail, it will bend. The same thing is here. So there is internal moment. How to calculate that internal moment? Do you know? For steel, you know that. How to calculate that internal moment? I hope you know that. And you have studied in strength of material.
Yes.
You know what is the meaning of strength of material? This is what I'm saying.
Yeah. Internal.
You know this equation? M is equal to Sx into sigma y or sigma?
No.
I think you should know that. Or you should know this equation. M is equal to, or the bending stress sigma is equal to M into y over I.
No.
You are lying with me.
Yes.
We know just M equals 0.
You have not studied this?
No, we reached chapter 4 and 6.
If you're saying this, you're lying. Because it is the most important equation in the history of structural engineering. Sigma is equal to M into C over I, maybe.
No.
We have to. Okay, but this equation gives you, this equation is like, it gives you the bending stress. And what is I over Y? I over Y is basically Sx. The same equation, I over Y is this. Or if you can say Ix. I will complain. I will complain to your teacher.
What?
So this is the internal resistance. Okay? How you can calculate by this on the same way. We have studied this equation how to calculate the shear stress.
Yes.
What is the equation for shear stress?
It's shear force over the area.
BQ over IB. No? What about the torsion? How to calculate the torsional stress? T into R over J. No, great. You are in my class, and you are gonna be engineers someday.
In the far future.
Not so.
Well, I'm a little bit surprised, but I don't waste your time. Okay, but these are the equations. These equations gives you internal forces, internal resistance. This is internal shear. This is the internal moment capacity. For example, this is like for the concrete, reinforced concrete design, you know, maybe around 5 weeks I take just to teach how to calculate the internal resistance of a concrete beam. The equation is this. This you don't know because it is a reinforced concrete design. Half of the semester I take just to tell the capacities of different beams. Okay? Because you know, analysis and design, they are parallel. What is design? I told you, to find out the required sizes. If you have, for equilibrium, the applied forces and the resistive forces, they should be equal. Do you understand?
Yes.
Which structure will be an economical structure?
If the load is like half or less of the resistance.
Economical will be that one in which the maximum expected resistance is equal to the applied load, maximum applied load, possible applied load. Okay, that's MU. If you want to find out the capacity, this is the equation. What is design? Design means to find out the required size or the reinforcement in case of concrete beam. This is if you know the maximum moment, you can find AS, the area of steel, and if you have AS, you can find out the maximum moment. So this is the same, capacity and design, they are parallel. If you know the capacity, if you know the size, you can find out the capacity. This is known as capacity analysis. And if you know the required force, you can find out how much should be the size. If you understand, very good. But if you do not understand, still you can pass this course. Okay? With A grade or maybe A plus. Okay. These are the equations of equilibrium. So you know that it is two-dimensional equilibrium. And for a two-dimensional equilibrium, the sum of all forces should be equal to 0 and sum of all moments should be equal to 0. Okay? Let's come to the point of concern. Next is degree of determinacy and degree of stability. There are two things, or in fact 4 things. Determinate. Okay, I think you have solved many problems in your statics. Let me change the marker. It's
When there are enough equations to find all the variables.
yes, that structure is indeterminate. For example, it is a hinge support, and you have one force like this, 10 kilonewton at 45 degree, 2 meters from here and 4 meters from here. How much will be the reactions?
We'll take the
Fx, Fy,
we'll take the vertical
and moment.
first the vertical.
There are 4 reactions. Like if I call A and I call this B,
Must be a
AB.
thickness.
VA, sorry, HA, VA, HB, VB, 4 unknowns. And how many equations do we have?
3.
3. You cannot solve this. Can you solve this?
If you give the thickness,
Okay.
it
The
will be
thickness
4
is
equation.
like 0.1 meter. Now, can you solve it? Just take the moment. If you take moment here or here, these two you can find. No? Yes.
We can't.
If we take the moment
You
at B,
cannot.
we will get the vertical.
We will get
If you take the moment here,
an X direction.
We'll-
you will find this
Yes.
only.
Yes.
And if you take moment here,
You will change.
VB.
you will find this.
Okay.
And the other equation is
Can't.
By the
sigma fx. Okay, I take sigma fx. HA plus HB is equal to like 10 cos 45.
Yes.
How to find HA and how to find HB? This is an indeterminate structure. And how much is the degree of indeterminacy?
We have two. We have two variables. So,
How many supports we have? 4.
yeah.
Two support.
Reactions, how many reactions we have?
Four.
4. And how many equations do we have?
4.
3. Sigma fx, sigma fy, and sigma m.
Yes.
So how much is the degree of indeterminacy?
1.
1. I mean, one reaction, if we find one more reaction, we can solve it. So any structure, for example, if I convert this to a roller,
We can.
3 equation, 3 reaction.
now you know how much is HA is equal to 100.
Yes.
And now you have 3 equations and 3 unknown. Okay? So now this structure is what? It is determinate. What about this structure? Indeterminate.
There is a 5.
And how much is the degree of indeterminacy? 2. And if I make a fixed support here, 3. This is the degree of determinacy and indeterminacy. Now let me tell you about stability. I think I told you something about stability.
Yeah.
If,
How to ideal.
okay, the same structure, but I put a roller here and I put a roller here.
Can be pushed.
So now this structure is what? This structure is determinate or not?
Determinate, but unstable.
Unstable. And if I put
You can eat this.
3 more rollers,
Undeterminate, unstable.
is it determinate now?
Undeterminate.
No, it is indeterminate and
Unstable.
unstable. Do you understand now?
Yeah.
Good. Now I tell you how you can calculate by this equation. There is one equation, R is equal to 3n. Or if you say R minus, if R minus 3n is equal to 0, it means your structure is statically determinate. We don't know about stability or not, but it is statically determinate. So let me tell you, there is also one condition. What is n? N is the number of members, number of parts. For example, in this case there was one beam, so n is equal to 1. If there is a member which has a joint, it will become 2 parts. For example, this beam is in 1 part, but if I put a joint here, it will become 2 parts. Now n is equal to 2. Okay? So let's solve some problems. And tell me, let me tell you one more thing. This support is a collar. I mean, don't consider this as a member. It is a support. Okay? It's a collar support.
Can fly.
I think I have shown you before.
Yeah.
Like this. This is a collar. This see this support. This is a collar. Can you see here? This support. Okay. This one. if you see this one, this is not a member. This is also not a member. This is a part of support. This type of support is known as, we call it collar. C-O-L-L-A-R, collar support. Okay. The same is here. Fixed connected collar. So I'm saying that if you solve any problem, don't consider this as a member. This is a part of support. So how many parts for this structure?
1, 2, 3.
2. 3 is support.
We have a beam.
Not considered.
Okay, hold on. I will tell you. There is one more condition. If that condition is satisfied, the structure will be unstable, and this is the condition. That if you have supports in such a way that the resultant of all these forces is passing through one point, then that structure will also be unstable. It will not be stable. Okay, for example, this is the example I have given you just some time before. This structure is determinate but
Unstable.
unstable. Now let's solve some problem. You will get the answer in this problem, okay? Now for this problem we have to calculate what? We have to tell that this beam is statically determinate or not. Tell me. This beam is statically determinate or not?
Yes.
Yes. The simple rule is R minus 3n is equal to 0. It is if this equation, or R is equal to, if they are equal, it means it is statically determinate. So now you can tell me about this structure. N is the number of members. How many members? 1. And how many reactions? 3. So R is the number of reaction. So it means, now let's talk about these structures. For example, see the topmost one, B. How many reactions? 5.
3 and 2. 5.
5.
6 and 2.
And how many number of members?
1.
1. So
5 minus 1.
5 minus 3.
Minus
3n. So the degree of indeterminacy is 2. Now let's see about C. Please see please. Any question? No? Okay, now if you talk about C, so how many number of parts? How much is M? N? 2. And how many number of reactions?
3.
5.
6.
5 or 6.
Hence that is 2.
6.
Roll up. Lunge.
6.
6.
Yes.
You know what I can see? I can see there's a mistake here. He has put a